3D model designed on the computer. In this case, we're going to be printing some physics anonymous keychains. If you don't know anything about 3D modeling, you can find tons of models that other people have created on thingiverse.com. Next, we load the model into Slicer. This is a piece of software that will convert our model into something our 3D printer understands. It does this by slicing the model in very thin layers, in this case 0.2 of a millimeter thick. There's way more to slicing software than I can cover in this video, but if you're interested in more detailed video about slicers, leave a comment in the doobly-doo. But for now, let's just say magic happens and we have a file that the printer can print. All we have to do now is copy the file to the printer and hit the go button. From there, the printer reads the file and starts heating the hot end. Then the raw material, in this case PLA filament, is pulled off the spool by the extruder motor and sent down a tube to the extruder. The extruder melts the filament and pushes it out this nozzle. The print head moves by the computer, drawing the shape for each layer of the object. Most FDM printers work in a similar way, but the Delta printer has a few key advantages. You may have noticed the Delta doesn't have any motors attached to the print head. Instead, they're hidden down here, at the bottom of the printer. This is a big advantage to the Delta design. Some of the heaviest parts in a 3D printer are the motors, and by keeping them static, the print head can move much faster with less chance of mechanical parts flexing due to shifts in momentum. Let's look at how the printer moves the print head left, right, up, down, forward, and backward. Let's simplify the design a little by taking out one of the arms so it's easier to see. You can now see if I move one of the carriages up and down, the print head moves left or right. You may have also noticed the print head moves up and down slightly as well. This would be pretty bad if we didn't have a way to keep the printer head at a specific height. Luckily, by also moving the other carriage at the same time in the opposite direction, we can move only in the direction desired. This seems simple enough, but the 3D printer has to look at each position it moves to and figure out what position the carriages have to be in to get to that position. This is called inverse kinematics, and it's one of the reasons Delta printers aren't more popular. Because the 3D printer has to make this calculation hundreds of times a second, you need a faster processor than you might with a traditional Cartesian printer. But lucky for us, processing power is cheap these days. Delta printers can also be a bit hard to set up because the printer's computer needs to know the exact shape of the 3D printer. This includes measurements like the arm length and the distance between carriages. But once everything is set up correctly, the Delta is one of the faster and more reliable printers out there. Now we can add the third carriage back in, add some ball joints to give us a little more freedom of movement, and that's it. That's how a Delta 3D printer works.